mentioned you've written about binary planets.
Yeah.
And that they're surprisingly common, or they might be surprisingly common. What's the difference between a large moon and binary planets? What are binary planets? What's interesting to say here about giant rocks flying through space and orbiting each other?
The thing that's interesting about binary objects is that they're very common in the universe. Binary stars are everywhere. In fact, the majority of stars seem to live in binary systems. When we look at the outer edges of the solar system, we see binary Kuiper belt objects all the time, asteroids basically bound to one another. Pluto-Charon is kind of an example of that. It's a 10% mass ratio system. It almost is, by many definitions, a binary planet, but now it's a dwarf planet. So
yeah,
I don't know what you call that now. But we know that these, the universe likes to make things in pairs.
Yeah. So you're saying our sun is an incel? It's looking. So most things are dating; they're in relationships, and ours is alone.
It's not a complete freak of the universe to be alone, but it is. It's more common for sun-like stars. If you count up all the sun-like stars in the universe, about half of the sun-like star systems are in binary or trinary systems, and the other half are single. But because those binaries are 2 or 3 stars, then cumulatively, maybe like a third of all sun-like stars are single.
I'm trying hard to not anthropomorphize the relationships the stars have with each other.
Yeah,
but
the triplets.
I've met those folks also. So is there something interesting to learn about the habitability, how that affects the probability of habitable worlds when they kind of couple up like that in those different ways?
Well, it depends if we're talking about the stars or the planets. Certainly, if stars couple up, that has a big influence on the habitability. Of course, this is very famous from Star Wars. Tatooine in Star Wars is a binary star system, and you have Luke Skywalker looking at the sunset and seeing 2 stars come down. And for years, we thought that was purely a product of George Lucas's incredibly creative mind. And we didn't think that planets would exist around binary star systems. It seems like too tumultuous an environment for a quiescent planetary disk, circumstellar disk, to form planets from. And yet, one of the astounding discoveries from Kepler was that these appear to be quite common. In fact, as far as we can tell, they're just as common around binary stars as single stars. The only caveat to that is that you don't get planets close into binary stars. They have like a clearance region on the inside where planets, maybe they form there, but they don't last. They are dynamically unstable in that zone. But once you get out to about the distance that the Earth orbits the sun, or even a little bit closer in, you start to find planets emerging. And so that's the right distance for liquid water, it's the right distance for potentially life on those planets. And so there may very well be plenty of habitable planets around the binary stars. Binary planets is a little bit different. Binary planets, I don't think we have any serious connection of planet binarity to habitability. Certainly when we investigated it, that wasn't our drive, that this is somehow the solution to life in the universe or anything. It was really just like all good science questions, a curiosity-driven question.
What's the dynamic? Are they legit orbiting each other as they orbit the star?
So the formation mechanism proposed here, because it is very difficult to form 2 protoplanets close to each other like this. They were generally merged within the disk, and so that's why you normally get single planets. But you could have something like Jupiter and Saturn form at separate distances. They could dynamically be scattered in towards one another and basically not quite collide, but have a very close-on encounter. Now, because tidal forces increase dramatically as the distance decreases between 2 objects, the tides can actually dissipate the kinetic energy and bring them bound into one another. So that seemed, when when you first hear that, you think, well, that seems fairly contrived, that you'd have the conditions just right to get these tides to cause a capture. But numerical simulations have shown that about 10% of planet-planet encounters are shown to produce something like binary planets, which is a startling prediction. And so that seems at odds with, naively, the exoplanet catalog, for which we know of, so far, no binary planets. And we propose one of the resolutions to this might be that the binary planets are just incredibly difficult to detect, which is also counterintuitive. Because remember how they form is through this tidal mechanism. And so they form extremely close to each other. Sort of the distance that Io is away from Jupiter, just a few planetary radii, they're almost touching one another. And they're just tidally locked, facing each other for eternity. And so in that configuration, as it transits across the star, it kind of looks like you can't really resolve those two planets. It just looks like one planet to you that's going across the star. The temporal resolution of the data is rarely good enough to distinguish that. And so you'd see one transit, but in fact, it's two planets very close together, which are transiting at once. And so, yeah, we wrote a paper just recently where we developed some techniques to try and get around this problem and hopefully provide a tool where we could finally look for these planets.
The problem of detection of these planets when they're so close.
That was our focus, was how do you get around this merging problem? So whether they're out there or not, we don't know. We're planning to do a search for them, but it remains an open question. And I think just one of those fun astrophysics curiosities questions, whether binary planets exist in the universe. Because then you have binary Earths, you could have binary Neptune, all sorts of wild stuff that would float the sci-fi imagination.
I wonder what the physics on a binary planet feels like. It might be trivial. I have to think about that. I wonder if there's some interesting dynamics. Like, you feel multiple, or would gravity feel different at different parts of the surface of the sphere when there's another large sphere? That's interesting.
Yeah, I would think that the force would be fairly similar because the shape of the object would deform to a flat geopotential, essentially, a uniform geopotential, but it would lead to a distorted shape for the two objects. I think they'd become ellipsoids facing one another. So it would be pretty wild when people like flat Earth or spherical Earth, you fly from space and you see a football-shaped Earth as your own planet.